morning or evening to everyone. You know, those not familiar with Cyxtera, we're a global co-location company with over 60 locations. And I've been asked to share with you today how we use RF code to enhance those operations. And specifically, Cyxtera uses RF code for temperature and humidity measurement. We've got over 10,000 sensors installed throughout our portfolio, supporting SLA management, customer reporting, and we use it also for energy efficient operations. So what you're going to see here is a view. This is what Trey was referring to as that single pane of glass, that home page. That shows all of our locations and just gives us a real quick single pane of glass, one glance view of our environmental status at all of our sites. And we can also drill down to any individual site or even a suite to see the installed sensors and their values. And with enough sensors installed, you essentially have a live CFD of sorts, identifying areas where we're too cold or we're too hot. And the ops staff can make adjustments and watch the impact of those adjustments on the screen live. Just as an example, and this happened just recently, we had a cooling event at one of our major centers. We logged into Centerscape while we're on the incident call, and as the ops team worked the issue, we could see the environmentals respond live throughout that center and immediately report areas not responding for additional mitigation. Literally, we had people from around the world logged into this screen, simultaneously observing the event recovery in a live fashion. Now, our operation and engineering staffs leverage that visibility to also influence our energy efficiency, which is really just reducing our energy expense. So how do we do that? Well, I'm sure most of you are aware, and this is old news, but I'm going to spin it a little bit of a different way here. But the best way to increase efficiency, or one of them, is to reduce or eliminate bypass air. Yeah, I know bypass air. We've heard it a million times over the last 10 years, but hang on here. So we spend a lot of money producing cold air intended to be delivered to the inlet of the IT equipment where it gets warmed and returned to the cooling system. This is the desired case. This is what we're looking for. Cold air being delivered to the IT equipment, all of that cold air passing through the IT equipment, and all of the hot air returned to the air handler, where it's then cooled and returned to the underfloor plenum. The higher the delta T at the air handler, the more efficient the unit. Air that returns to the cooling system, never having passed through the IT gear, is bypass air. I think most of you know that. So in this next slide, we see bypass air reducing the return air temperature, reducing the delta T by mixing with the hot air exhausted from the IT equipment, and this is reducing our efficiency here. Now, there are a lot of ways to combat bypass air, especially as shown here. I think we're all familiar with cold or hot aisle containment, but those systems are expensive, and they each have all their pros and cons. So as an alternative, we use our RF code sensors to employ virtual containment. So what we do is we install a sensor near the top of every third cabinet or so, and we vary that placement depending on the power density of our adjacent cabinets, or where we see big power density distributions, we might put more in that area. And we monitor those temperatures, setting alert thresholds. So what you're seeing in this diagram is we're delivering too much cold air to a cabinet. The cold air is not being ingested by the IT cabinet, and it passes over the top of the cabinet and returns as bypass air, reducing the delta T at the air handler and reducing our energy efficiency. So the respective sensor, which you see at the top of the cabinet there is that little green dot, is going to show a lower temperature indicating we have a bypass air condition. So our ops staff can respond, rebalancing the louvers on the perforated tiles or in the ducts delivering the cold air. What we do is we reduce the cold air volume delivered to only that which is required by the cabinets. And what that does is that returns the temperature sensor back to its set point, because we're no longer bypassing cold air across that sensor over the top of the cabinet. Now, in this case, we're overcooling, which is mostly an efficiency issue, though we do have low temp SLA limits as well, but in this case, it's more of an efficiency issue. Alternatively, as you can see in this slide, if we see a sensor warming up, it suggests we're not delivering enough cold air to those cabinets, and hot air is being recirculated to the IP inlets across the top. That hot air passing the RF code sensor reports an increased temperature alert. And again, the alert is generated. The ops staff adjusts the cold air delivery to return that sensor to its set point so that we're filling the cold aisle with just the right volume of cold air, which is the volume of cold air required by the cabinets served by that cold aisle. So in this instance, we're actually undercooling, and that's more of an SLA issue. So when we started doing this, our concern was that our floor techs would be running around like crazy, making adjustments continuously, and we just found that wasn't the case at all. The floor temperature variations simply weren't nearly as dynamic as we feared they might be, and these location-specific adjustments were maybe just a few a day. And then the teams learn through experience over time how their sensors react, and of course they adjust their response accordingly. All right, so that's the efficiency by managing the cold aisle in this case, and essentially virtual containment, because we actually don't have any hard containment there whatsoever. But beyond the energy efficiency by virtual containment, this increased granularity in our measurements allows us to manage our floor temps with much greater precision. This allows us to warm up our supply air temperatures. Now, ASHRAE recommends 80.6 degrees Fahrenheit as the max inlet temperature, and that is the SLA that we promise to our customers. And to ensure that we never, ever exceed that, we might set our supply air temperature at, say, 70 degrees. And that gives us a lot of headroom to react to a potential event without violating our SLA. However, given the operational discipline afforded by these RF code sensors and leveraging the CenterScape monitoring tool, we are far more comfortable increasing those supply air temperatures, in essence, warming up the data center. And what we're doing is we're reducing that former protective temperature guard band, and that also further decreases the amount of energy we're consuming to cool our data centers. So while the RF code temperature and humidity sensors obviously do a great job satisfying our SLA management and customer reporting requirements, we also use the sensors to ensure that we maximize the delta T seen across our air handlers, and it also allows us the visibility and the comfort to start operating our data centers at higher supply air temperatures, warming up the data center, all in all, reducing our annual energy expense. So that's what virtual cold aisle containment is, and that's how we're using RF code to enable that within our data centers and save us an awful lot of money. And with that,